Hey everyone, this is a somewhat belated video on the synthesis of dinitrophenyl oxalate, the main component for demonstrating the glow stick reaction. The synthesis isn't complicated, but only if you're in a lab. For this synthesis, you need dinitrophenol itself, which I synthesized in one of my previous videos. Next, you need triethylamine, which I bought. Then there's oxalyl chloride, the most difficult reagent to get your hands on. Try to obtain it outside of a laboratory. And if you do, you need to work with it carefully because its toxicity is similar to phosgene. It even has a similar structure. Proper ventilation is a must-have. For the synthesis, you also need solvents, dichloromethane and chloroform. All reagents except oxalyl chloride need to be dried. The reaction is very sensitive to water. Water in the solvents significantly reduces the yield. I didn't dry anything and then deeply regretted it. Some people use toluene as a solvent, which is easier to dry. Unfortunately, toluene is hard to come by here, so I use dichloromethane as a solvent. The reaction itself is very simple. It's a standard acylation of dinitrophenol with oxalyl chloride, forming an oxalic acid ester, with the evolving hydrogen chloride being captured by triethylamine. I added dinitrophenol to a flask, dissolved it in dichloromethane, and then added triethylamine. I cooled it to 10 degrees C and started to add oxalyl chloride dropwise. The product is almost insoluble in dichloromethane and should start precipitating immediately. However, nothing precipitated for me until I had added 2/3 of the total oxalyl chloride. This could only mean one thing: water in the dichloromethane and possibly water in the triethylamine. And everything that happened up to that point was the reaction of oxalyl chloride with water. We were just drying the reaction mixture in such an expensive way. So I added all the oxalyl chloride. Then I decided to compensate for the reduced yield by adding a 1.5-fold excess of triethylamine and oxalyl chloride. Generally, taking an excess of scarce oxalyl chloride isn't ideal, and next time I'll simply dry the reagents. You can do this with molecular sieves, for example. After 15 minutes, I filtered the product. There was a lot of precipitate on the filter, but it wasn't just our product, it was also a large amount of triethylamine hydrochloride. It dissolves in chloroform, so I washed the precipitate on the filter with chloroform 3 times. Now on the filter I have pure dinitrophenyl oxalate. All that's left is to air dry it to remove the chloroform. I achieved an 80% yield. Now I have the reagent to demonstrate the glow stick reaction. I've already made a video about it. Click the suggestion to watch it.